Okay, what makes a significant figure? Well, first of all, significant figures are going to be based on the quality of the measuring device. Because if we're having a measuring device with lots of markings and we can get really, really accurate, that's a good measuring device. Now, if I have this graduated cylinder, notice how this person is looking at the bottom of the meniscus here. And that bottom of the meniscus, she's reading or he's reading at 32.0. Now, why is that 0.0 important? It's important because it tells us the quality of that measuring device. It's telling us, look, all these marks are here, and the person reading it thinks that that mark is falling exactly right on that 32.0. Now, what if they were reading the meniscus and they thought, well, right between there, I've got a really thick marker here, so, but let's say they thought right between there, you know, in the middle or somewhere in between. Well, then they would have read it as 32, 33, 34, 34 point, oh, I don't know, 7, 34.8, 34.6. It's hard to tell there, but that is an estimate that we're going to make. And she is estimating, the reader is estimating the 0 here because they think, well, it's right on the line. So the quality of this measuring device basically tells us, look, we've got this many marks, plus we're going to make one estimate. And so it's a fairly good measuring device. There are better out there, but this one's pretty good. So significant figures are going to be all the markings on the measuring device. And this is going to be really important. That's device. This does not write very well. Plus one estimate. And that estimate is really important that you make that, especially like the zeros. Because I think people tend to say, well, 32, that's it. But you do have room. You're going to make an estimate. And if you think it's right on the line, then do 32.0. In the same sense, and I'll try to draw a little ruler over here. Let's say we're measuring centimeters. We have 1, 2, 3, 4, 5, 1, 2, 3, 4, and then we have 2. Okay, so say these are centimeters, and you want to measure something that's, oh, I don't know, like right there, okay? Well, you probably say 1.56, and then you have to make an estimate, and I'm going to say 5. Now, if you say 1.66, that's absolutely fine, but that estimate's important. Okay. Now, what if you think you're going to measure something else here and you think, yeah, right there, okay, right on that line. Well, then it's important for you to measure that as 1.50 because you're saying my estimate is that it's right on the line, that 0. Okay, so be careful. And of course, always, always, always put units on things because I get confused. If you don't put down a unit, then I might think, well, you know, what is that? 1.50 croutons, centimeters, what is it? Okay, so there are some rules for significant figures when you are given a measurement. So let's say you're given measurements, and of course you are all the time, right? In the textbook, on worksheets, that kind of stuff. So definitely look up on page 145 all the rules for significant figures when you're given a measurement. And they have rules for, you know, non-zero numbers are always significant. Zeros, sometimes they're significant. If they're preceding zeros, no. If they're captive zeros, yes. If they're trailing zeros, yes. If there's a decimal point, no. If there isn't a decimal point. So it gets a little bit confusing. I've got a little trick that will help us do that, but I think it's definitely worth reading those rules, okay? The other thing that's good on page 145 is the fact that they talk about exact numbers because not everything is a measurement. You know, you could have 10 people in a room. You're not going to say, well, I have 10.1 people or 10.0 people. I mean, it'd be kind of silly. You got 10 people. Okay, but if you are talking about a measurement, here's one little thing you can do instead of doing these rules. You can think of a measurement within a map of the United States. Now, I'm not going to do a wonderful job of this, but we got Michigan. I love Michigan. Minnesota. Okay, I know I made it a little flat there, but we have the Pacific Ocean and we have the Atlantic Ocean. Now, what you do with these measurements is you think about them as either having a decimal point that is present or a decimal point that is absent. And if the decimal point is present, we're going to start on the Pacific side of the number. And if a decimal point is absent, it doesn't have a decimal point, then we'll start on the Atlantic side. Now, I do want to put this into scientific notation and talk about it in that sense too. So that 0.0020 is also, of course, 2.0 times 10 to the negative 4. Okay, so here's the rule. If the decimal point is present, we start on the Pacific side, the left-hand side of the number. And if it's absent, we just start on the right-hand side of the number. So everything else is pretty much the same at that point. Now, once you've decided that. So you're going to start on whatever side you're going to start on. And you're going to go to the first non-zero number and count from there. And that tells you how many SigFigs. So let me show you. 2,000. Decimal point is absent. There's no decimal point. I'm going to start on this side of the number. I'm going to go to the first non-zero number and count from there. 1. This number has 1 SigFig. And quite honestly, if you think about that measurement of 2,000 meters, that would be like you looking out the window and say, you know, I think that tree over there is 2,000 meters away. Well, what kind of measurement is that? That's not a good measurement. I mean, sure, it's not 2 miles away, but, you know, it's kind of a bad measurement. So 1 SigFig is pretty much all you're going to get. Not a great measuring device. Now, decimal point is here at 2000.0. Present, I'm going to start on this side of the number, go to the first non-zero number and count from there. So 1, 2, 3, 4, 5. This number has 5 SigFigs. But again, it makes sense. If someone were to say this is 2,000.0 meters away, unless they were lying to you, they got some equipment out there, surveying equipment, lasers. They got some, you know, a good measurement. 2001, decimal point is absent. I'm going to start on this side of the number. Go to the first non-zero number and count from there. 1, 2, 3, 4. This has 4 SigFigs. Now again, that's a fairly good measurement. 2001. So again, unless someone's lying to you, it's a pretty good measurement. All right, how about this one right here? Decimal point is present. I'm going to start on this side of the number. I'm going to go to the first non-zero number and count from there. 1, 2. This has 2 SigFigs. Notice I quite often put these into scientific notation because decimal points present, go here, count from there, 2 SigFigs. The base is going to tell you how many SigFigs, the times 10 to the negative 4. You don't need to look at that for SigFigs. Once you have SigFigs down, why are we doing it? Because we calculate stuff. And when we calculate stuff, there's a lot of numbers on our calculator, and we do not want to write them all down. Now, I know in calculus, for your AP Calc test, you have to round like 3 places after the decimal. That's, you know, just for everything. In science, you have to look at the measurements and how good are the measurements. So, for multiplication and division, if I'm going to do that, I'm going to round my answer. Wow. I'm going to round my answer to the least number of significant figures in any of the numbers I've used for calculation. Your chain is only as good as its weakest link. So if you take a look at 356 centimeters and 7 centimeters, on my calculator, I get 2,492 centimeters squared. Well, the units, but you're good on units. Now, why do I have to round this to 2,000? Well, you know, most people don't want to do that. They would probably, if they had to round it, want to go with me 2,500. But here's the thing. Look at that measurement. That is a terrible measurement. That I can't even imagine a ruler that would, you know, that's your estimate. That's like looking at a blank ruler and saying, I think it's about 7 centimeters. Okay, so that's a terrible measurement. So your answer has to reflect that terrible measurement. Okay, so if you had maybe 356 times 7.0, now that's a little bit better. I could round this now to 2,500. Okay, and if I could, you know, even get it a little bit more accurate, 7.00, I could do even better than that. So just be careful. This is for multiplication, division. Round your answer to however the least number of SigFigs. So here has 3 SigFigs, that only has 1. Round your answer to 1. Now the rules for addition and subtraction are actually very different. They still encompass this whole idea of uncertainty, but it is a very different rule. what we're going to look at places after the decimal, not the total number of SigFigs, which I know is a little annoying, but we're going to look at places after the decimal. We're going to look at all our measurements, look at their places after the decimal, and the least number of places after the decimal is what we will do for our answer. We'll round that to that number of places after the decimal. So we look at this, and 34 doesn't have any places. This number, of course, has 2 places, 0 places. I punch this into my calculator, but I have to round it to that. No places after the decimal.